name's Tenley. Want to do this math problem? What's 2 plus 100? It is 102. Here's my mommy.
It's my little assistant, Tenley, with a math problem for you. She wanted to hang around and do some SAT prep too, but she decided it's nap time, so that's where she's headed. Our next question comes from part C. It is number 9. In the equations above, I have them right here. T is a constant, and we run into that word constant all the time. And think about driving your car in cruise control. If you remain at a constant speed, you're at a value that never changes. So all it means to be a constant is your number. The value of 6 doesn't change. The value of 90 doesn't change. So T just represents an unknown number. Which of the following equations correctly relate X and Y? And while that may not be very apparent what it is we're supposed to do, a really great testing strategy is to glance down at the answers. And glancing down at those answer choices, I realized T is nowhere to be seen, so we know that we need to get T to disappear. One great way to make any sort of variable disappear is to make an equivalent substitution of that variable that doesn't utilize that variable. So in order to make that substitution, I'm going to pick one of my equations. I'm going to start with my first one, and I'm going to solve for T. So to solve that first equation for T, I'm going to subtract 6 to the other side. And I am going to divide off the 2, and I'm going to divide every term on the left side by 2 to get 2x minus 3 equals T. Now that I have an expression that is equivalent to T, I'm going to take that expression and I'm going to substitute it in for T in our second equation. Now, unfortunately, I'm going to have to get rid of some of Tenley's math here. And here we go. We're going to make that substitution. So in that second equation, we have 2y equals 3. Oh, wait, instead of T, I am going to substitute 2x minus 3, and we have minus 5. Now, glancing again at my answer choices, I realize that all of them are in standard form of a linear equation, which means x and y are on the left side of the equal sign and our constant is on the right. So I'm going to distribute combine like terms and move around my variables so that I'm in standard form. So distributing that 3, we have 6x minus 9, and I still have that minus 5. Combining like terms, we have 6x minus 14. And subtracting that 6x over to the other side, we have negative 6x plus 2y equals negative 14. And now that I'm in standard form again, I'm going to glance at my answers and I realize, hey, nothing matches. But glancing down at D, I realize D is the only one that has a coefficient of x that is negative and a constant value that is negative. And looking a little further, I realize that all of the coefficients in D are half of the value of the coefficients of what I have. Now, we know with any equation, whatever I do to one side, if I do the same operation to the other side, I'm not changing the value of the equation, I'm just expressing it in a different form. So in order to get this to match option D, I'm going to divide both sides entirely by 2, and we get our negative 7 matches up with D. 2y divided by 2, y, don't mind the beeping, it's our oven. And negative 6x divided by 2 is negative 3x. And there we go, we have option D. Hopefully that helped.